Now let's explore the different components that make up the pulse sequence dashboard. In the pulse sequence diagram, you will see a visual representation of the timing of RF pulses, gradients, and MRI signal. This area will be the basic pulse sequence diagram for the pulse sequence being displayed. The pulse sequence determines how and when the MRI turns on certain hardware components. You will also see when RF delivery, slice encoding, phase encoding, and frequency encoding are taking place from a hardware standpoint. In the upper right-hand corner, you will see a visualization of the net magnetization vector and its relationship to B0, or longitudinal magnetization, and B1, or transverse magnetization. Directly below the net magnetization vector section, you will see the phase section, which will provide information on the phase coherence of the protons. In the K-space section, you will see how we are filling K-space in individual pulse sequences with the recorded MRI signal. If we look at the pulse sequence diagram, we see that the phase encoding gradient appears differently than the other gradients. This is because, based on the phase resolution of the desired image, we need to repeat the pulse sequence that number of times in order to fill K-space. Each time we fill a new line of K-space within the pulse sequence, we alter the strength of the phase encoding gradient. That is why it looks like a ladder. So, the only thing we are changing within a pulse sequence each time we are acquiring data within a given slice is the phase encoding gradient. Radio frequency bandwidth, slice, and frequency encoding gradients all stay the same. The RF excitation pulse will deliver energy to the patient and cause the flipping of the net magnetization vector. We can only record the component of the net magnetization vector into the transverse plane B1. The protons will begin to lose energy and dephase after the RF excitation pulse is turned off. The spin-spin interaction, or dephasing, is controlled by T2 and T2 star and results in the loss of transverse magnetization and the MRI signal. As the protons lose this coherence and dephase, the MRI signal is reduced because not all of the protons are pointing in the same direction. The MRI signal is recorded in K-space during frequency encoding, which is left to right. The phase encoding gradients determine what line of K-space we will be recording from top to bottom. You can think of a pulse sequence as the pulse sequence recipe. As the operator, you are able to change aspects of the pulse sequence by entering certain parameters at the console. Repetition time, or TR, and echo time, TE, are just two examples of these parameters, and we will cover them as well within the pulse sequence animations.